Welcome to the how-to video for the size of atoms. When we talk about the size of an atom, we could really think about drawing out the two-dimensional shape of the atom. And in this case, we could start with sodium. Sodium has an atomic number of 11, which means it has 11 protons and 11 electrons in the neutral atom. And as we can see from there, we have 2 in the n equals 1. We have 8 in the n equals 2 shell, and then that leaves us one more left in the n equals 3 shell. As we move across the periodic table from left to right, we would encounter magnesium. Magnesium has an atomic number of 12. It has 12 protons and 12 electrons, so 2 in the n equals 1, 8 in the n equals 2, and 2 in the n equals 3. If we move further across the periodic table and we encounter sulfur, sulfur has an atomic number of 16, so 16 protons, meaning 2 in the n equals 1, 8 in the n equals 2, and 6 in the n equals 3. If we understand the effective nuclear charge, then what we're essentially saying is that these electrons in the valence shell are being attracted to the nucleus. So we can think about this electron being attracted to the nucleus, this electron being attracted to the nucleus, and each one of these electrons are also being attracted to the nucleus. And so in this case, when we really think about what's happening to the size of the atoms, well, as the charge in the nucleus increases, as we go from plus 11 to plus 12 to plus 16, the overall charge in the center is growing, which causes those individual electrons to be pulled closer and closer to the nucleus. Thus, what we see is that as we move across the periodic table from left to right, we decrease in size, and so we get decreasing size of the atoms. As we move down the periodic table, we're now adding another electron shell. So the difference between sodium atom and a potassium atom is that now we have this n equals 4 electron shell, because now the n equals 1, the n equals 2, the n equals 3 have those electrons. The n equals 4 has 1 electron in the potassium. But in potassium we have one more electron shell, which is going to make it bigger than sodium. So as we go down the periodic table, as we know we have these periods, 1, 2, 3, 4, 5, 6, 7, which also tells us how many electron shells there are. So as we go down the periodic table, we know that we're also going to be increasing in size. So the way I like to think about it is use the periodic table. Draw yourself a picture and say that you know that as you move down the periodic table, you're increasing in size, and as you go from right to left, you're also increasing in size. This is going to help you remember the trend. Now for an ion, ions are a little bit different, and we have two types of ions. We have anions and we have cations. So let's forget about everything else and let's just talk about sodium. So if we look at sodium and we said, okay, well, we have the sodium atom. But now we want to talk about the sodium cation. The sodium cation means it has a plus charge. This plus charge really means that we lost an electron. Well, where's that electron going to come from? Well, it's going to come from the outermost electron shell. So when we really think about what's happening then, is for the sodium ion, we still have 11 protons. That doesn't change. What does change is the number of electrons. Where now we still have 2 in the n equals 1. We have our 8 in the n equals 2 electron shell. But what did we just eliminate? Well, we eliminated the third electron shell. And so the way I like to think about this is cations are smaller than the parent atom. And that's because we've eliminated an electron shell. When we look at anions, anions would just have a negative charge, and so they're actually going to be the opposite. Anions are going to be larger than their parent atoms. And so these are really the rules that we can remember for the size of atoms and ions. This concludes the how-to video for atoms and ions.